Have you ever wondered how birds and insects manage to glide, hover, or soar through the air so effortlessly? It's a fascinating question and one that connects us to the wonders of nature. The ability to fly is something humans have envied for centuries. While we've built planes to mimic birds and insects, the natural world still does it best, having evolved over millions of years to create perfectly adapted flying creatures. Today, let's dive into the science behind why some animals can fly and why others can't. When you look up and see a bird flying, what you're seeing is an incredible combination of physics and biology. To fly, an animal needs to overcome gravity and maintain momentum. This is done through three essential forces: lift, thrust, and drag. Lift is the force that allows an animal to rise into the air, and it's created by the wings. The shape of a bird's wings, or an insect's wings, is key here because it helps direct the air in such a way that it pushes the animal upward. Thrust is what moves the animal forward, and drag is the resistance they face as they move through the air. Together, these forces work in perfect balance to keep birds and insects in the sky. Now let's talk about evolution, because flight didn't just happen overnight. Birds and insects have developed these abilities over millions of years. For example, birds have lightweight, hollow bones that make it easier for them to get off the ground. This reduction in weight is key to their ability to fly, especially since they need to lift their entire body using their wings. Take the albatross, for instance, a bird that has one of the longest wingspans of any species, over 11 feet. With such large wings, the albatross is able to glide over the ocean for hours without flapping, using wind currents to stay aloft. Insects, on the other hand, use rapid wing movements to stay in the air. Honeybees, for instance, flap their wings about 200 times per second. It's incredible to think about how such tiny creatures can generate enough lift and thrust to hover, dart around, or even fly backward. Dragonflies are another perfect example of insect agility. They can change directions in a split second, a skill that has inspired drone technology today. One of the most important adaptations in birds is their feathers. Feathers play a critical role in flight by allowing birds to control the air flowing over their wings. The lightweight but strong nature of feathers means that birds can minimize drag, and the arrangement of their feathers helps them steer and maintain stability. If you've ever seen an eagle soar or a pigeon fly around a city, you'll notice how effortlessly they control their flight, thanks to the precision of their feather arrangement. But not all birds and insects have wings designed for flight, and some have evolved to live without flying altogether. You might wonder, why would a bird evolve to not fly? It seems like a disadvantage at first, but that's not always the case. Flight takes up a lot of energy, and in certain environments, flight isn't necessary or can even be a disadvantage. For example, birds like the kiwi in New Zealand have lost the ability to fly because their environment has few predators. Over time, their wings became smaller and they adapted to a ground-based lifestyle. The same thing happened with the dodo, a now extinct bird that lived on the island of Mauritius. With no natural predators, the dodo didn't need to fly to escape danger, so it evolved into a flightless bird. Insects also show similar patterns. While many insects can fly, others have lost this ability. Ants are a great example. Most ants are wingless, but reproductive ants like queens have wings for specific purposes, like finding new places to establish colonies. For the rest of the colony, wings aren't needed, and the energy saved from not flying can be used for other important activities like foraging or defending the colony. What about birds that have wings but can't fly? Think about ostriches and emus. These flightless birds evolved to become strong runners, using their powerful legs to escape predators instead of wings. In fact, ostriches are the fastest running birds on the planet, reaching speeds up to 45 miles per hour. While they can't take to the skies, their legs are a different kind of superpower. In some cases, flightlessness isn't about survival in predator-free environments, but about adapting to specific niches. The kakapo, a critically endangered parrot from New Zealand, is another bird that gave up flight. Instead, it uses its wings to glide down from trees, but it's primarily a ground dweller. Like the kiwi, the kakapo thrived in a place where flight was no longer crucial. Flight, however, is not just limited to biological creatures. Engineers are constantly inspired by the way birds and insects fly. Drones today are modeled after the hovering techniques of hummingbirds and dragonflies. These tiny flyers use precise wing movements to stay suspended in the air while conserving energy, a feature that's perfect for drones needing agility in tight spaces. Even commercial airplanes take inspiration from the design of bird wings. The way birds like the albatross glide is studied to make aircraft wings more efficient, using less fuel while traveling long distances. So, while we might think of flight as something only birds and insects do, the truth is that their natural abilities have inspired human innovation in countless ways. The evolution of flight has been shaped by millions of years of environmental changes and survival needs, and it's something that continues to fascinate scientists and engineers alike. In the end, the reasons why some animals can fly and others can't all boil down to the environment, evolution, and the need to survive. Flight is just one of many remarkable adaptations in nature, a powerful example of how life can evolve to fill specific niches. Whether it's a dragonfly darting through a garden or an eagle soaring high in the sky, flight remains one of nature's most awe-inspiring abilities.